Okay, so let's get started adding database functionality to our little application. The first thing that we need to do is we're going to need to import Flask SQL Alchemy. So that's what we're going to do now. Now that we have that imported, what we need to do is we need to modify our application. Remember, this is our application. It's a Flask application. We're going to need to set some values in that application so that Flask knows where, and Flask SQL Alchemy knows where the database is. So the first thing we're going to do is we're going to configure the database URI, which is the thing that points to where our database is. Okay, so in this line, what I've done is I've set configuration value for our Flask application. The actual key is the SQL Alchemy database URI. The value that I'm setting it to is this one right here. Now this and other things that I'm doing with SQL Alchemy are all described quite clearly in SQL Alchemy tutorial pages and quick start pages. So I'm not deviating from the norm here. SQLite is a simple in-memory database that allows you to do database type things like have tables, make read requests from the database, filter the data that you get back, write stuff to the database, etc. Just as you would with a normal database, but it's much more lightweight, as the name would suggest, and simpler to use. So that's why we're going to be using that, at least at the very beginning. Now the last thing that we're going to do here is we're going to set our variable called db to be this SQL Alchemy class object, and we're going to pass into it the actual application. So we're going to end up with a variable called db that we will be referencing elsewhere. The type of data it is, it's an object of this SQL Alchemy class. And when we created it, we passed in the application that actually was the thing that is representing our Flask application. So the next thing to do is let's see if this actually works. Let's see if we've broken anything. So Flask was running from before. I'm going to stop it. I'm going to say Flask run. If we have a problem with the database or something, it will tell us. You'll notice here we're getting this message that tells us about SQL Alchemy track modifications, and it gives us a little bit of information about how to get rid of it. So we will do that in a little bit, but for right now it looks like we're running successfully. What I'm going to do is I will go back to our Postman and I'm going to attempt to get the data once again. So we've got the data. It looks the same as it did before. I haven't done anything with it. All I've done is added this functionality here, which is getting us started with creating the database. But we know that at least that part of it, we haven't broken anything in the process. The next thing that I'll do is I'm going to go and do what they recommend in order to get rid of that message. Let's type this in. So I've set that value to false. If I've typed it right, then we'll see if this actually works. Let's close this down. Run it again. And sure enough, we've gotten rid of that particular notification. So now at this point in time, we have SQL Alchemy getting loaded, and we have the database set up. And the next step will be to define our model and begin to use it. Okay, so let's continue with our definition of database stuff. Now we've imported this SQL Alchemy thing. The reason that we needed to do that was so that we can create an SQL Alchemy object that we're going to refer to as DB. That's our database. We also did some modifications of app. Remember, app is our Flask object, and we modified some configuration parameters. One of them being pointing the application, the Flask application, at the SQL Alchemy database. And so we're using SQLite, as you can see. So we've defined the mechanism for dealing with database stuff. What we need to do now is we need to begin to define our database tables themselves. And the way that you do that is you create a class that is going to be a type of database model class. So if I was to pull over for you my actual Python code for quokka, I know this is a little bit small, but if I was to show you here, I want you to be able to see it all on the same page. This is how my device class is defined right at this moment in time for the spot that I'm at with quokka. You can see I have SLA stuff in here. I have transport, that's going to be Napalm or netconf or REST API for my SD-WAN stuff. I also have compliance stuff in here. I have SSH access for doing netconf or Napalm or whatever. So I've got a bunch of stuff in there, but I'm not going to use all of that. I'm going to use a limited amount of those things at the beginning just to keep it simple and so that you can see how easy this stuff is. And in order to do that, another thing I'm going to do is this. My devices.yaml file is where I'm currently at with respect to reading in a bunch of information to start me off with identity and access mechanisms or access parameters for each of these devices. Now, I'm not going to use all of these at the very beginning. So what I'm going to do is I'm going to go through and make my devices.yaml simpler. And then when we go later on and we begin to do a more fuller and robust implementation that has more stuff, I'll add these things back in. So right now, all I'm really going to care about for a device is the IP address. I'm going to have a device name. I'm going to have an operating system for the device. I want to have this host name. That's just useful. We might as well keep that in there. And we're going to do vendor. So I'm going to go through here and edit this, and I'll speed it up so you don't have to watch me do that. I'm also going to get rid of all of these SD-WAN devices because they complicate things a little bit, and we'll deal with those a little bit later. So I'll go ahead and do that now. Okay, so it looks like I've made the changes appropriately and I don't have any errors. What I'm going to do though is I'm going to go ahead and test. In general, it's a good idea every time you make a change of some type of any significance that you test to make sure that it's running correctly. If you wait and make, say, 5 major changes and then you run a test, if it doesn't work, you don't know which of those 5 things that you just did is actually at fault. But if you do them one at a time, incrementally, and do tests one at a time, then you have a better chance of figuring out exactly what it is. So I'm going to go to my terminal. I am going to run Flask. It started up. That's good so far. Let me run my HTTP request. It's sending the request, and here's my data. Now, one thing that you'll notice is this data actually, there's less of it, right? I got rid of a bunch of things. There's 1, 2, 3, 4 devices, and they all only have host name, ID, IP address, name, OS, and vendor. So that's good. It's a good, simple starting point, and now we can begin to actually write the database code. So let's go back to our init. As you probably know, we will be putting this into models at some point, but in order to keep things simple here at the beginning, and so that you know that you don't have to do a big elaborate project structure, you can just define your data right here. I'm going to go ahead and do that. Now, the way that we create tables or classes for our models in SQL Alchemy is we use Python's object-oriented functionality, which is called class. Class is how I define a class, not surprisingly. And what I'm going to do is I'm going to give it a name. I'm going to call this class device. So this is going to represent a class. Now the other thing that's new here, well, it's all probably new if you don't understand the object-oriented capabilities of Python, but what is extra to this is this. What I'm going to do is I'm going to say I'm creating a class called device, but I want this to inherit from this thing called db.model. db, remember, is our SQL alchemy item here, and I have defined my database, my SQL alchemy, and I'm going to say I want this device, this class called device, to inherit characteristics from db.model. This is the magic that is going to make it possible for me to just create a Python class and to write this class to the database, and all the messy and nasty database stuff is taken care of for me by SQL Alchemy. So I'm going to continue to define this class, and I come down here, I'm going to define a number of things. First, remember I have the ID, and I'm going to say ID equals db, there's db again. I'm going to say db.column, and db.column I'm going to further define to say that this type of column is represented by an integer. So I'm going to say it is of type db.integer, and furthermore, one last thing that I'll do for this, I will specify that the primary key is this particular item. So at this point, I have defined one field in my table called ID. I've specified that ID is a column, and its type is an integer, and it is a primary key. So primary key is actually true. So now I'm going to go ahead and define another column, and that is going to be name. And I'm going to say name equals db.column. And the type of this column is going to be db.text. So what I'm specifying is that this is going to be a textual column. And I'm going to give it a couple other characteristics. One is I'm going to say, and you may or may not want to do this, I'm going to say unique equals true. This will cause SQL Alchemy to prohibit me from attempting to write two different rows with the same name. Now, it depends on your environment. If you have an environment where the name might be the same for different devices in different domains, maybe with remote devices or something of that nature, then maybe you want this not to be true. But this is what I've done in my implementation, so I'm going to leave it right there. The last thing I'm going to do is I'm going to say I want this not to be able to be null. So I want there to always be a name. Now the next thing I'm going to say is IP address. I'm going to say IP address equals db.column, no surprise there. And its type is going to be db.text. Now, as we move forward with the class and with understanding quokka, I will probably be changing this to a type of IP address that we will inherit from one of the libraries that implements IP addressing functionality. But for right now, let's just keep it simple and keep it as a text. The next thing I want to do is I'm going to specify the vendor and say db.column, and as you might expect, this will be db.text. And lastly, I'm going to do OS, and my OS is going to be db.column. So at this point in time, I have defined this class called device, and it has 5 different columns in it if you think of it in a database table manner. If you want to think of a class as something similar to a dictionary, this is like the key, although it's not really a key. These items right here, and then this will be the value, and the value in this case will be of type integer, and all the other cases it will be of type text. And now we will be able to utilize this functionality from db.model that's provided to us by SQL Alchemy in order to read and write items to our database. Hey, I just wanted to point out that yes, I did omit hostname from my definition of device. So when we pick up with the next little segment, you'll see hostname has appeared, and I think I'll make reference to that fact. Okay, so let's briefly review what we've done. We moved the views into its own Python package and into its own module so that we removed it from init.py. Then we started to work on database stuff, and we did the importing of SQL Alchemy and the creation of DB, which is of type of the class SQL Alchemy. We passed in the application, which is what was created, which is a Flask application. We also set a couple of configuration parameters. This one here tells it that we're using SQLite. This one here tells it not to track modifications. And then we began to create actually our database code, and our database code is just a nice Python class here. I've created a class called device. It is inheriting from this db.model thing, which is actually an SQL Alchemy child. So it is inheriting SQL Alchemy traits. And I defined a number of fields here. And if you have an eagle eye, you'll notice I've added one down here. I realized as I was preparing for this next step that I omitted hostname. Remember when we look at this, I left hostname in there, and that would actually cause a problem if we try to create or write data to the database and we have data in our Python that we've read in and we're trying to write it to the database, but there's not a column that is associated with that. So I added that in. Now the next thing that we need to do is this. We're going to have to go through and create our database. And the way that we do that is we just use db. Remember, that's the thing that we created up here. So I'm going to say db.create all. You can see it helpfully gave me that as an option. So I'm going to do db.create all. What that's going to do is it's going to tell SQL Alchemy, hey, take everything that I've defined in terms of database tables, which would be this one right here, and make me a database that follows that. In other words, I'm going to create a table in the database that has these 6 different columns. And that's what that is going to do. Now it's going to be empty, of course. I don't have any data here yet, but it's going to go out and create that. Now the next thing to do is we're going to want to read in the data from our YAML file. We're going to want to read it in, and remember, we have this handy function that we've created called import devices, which returns a list of Python dictionary devices. So we're going to be able to utilize that in our code here. So what I'm going to do is I need to first point Python at where I am getting this from. So let me do the import statement. Now that I've done my import statement, I'm going to be able to write the code to go through that list of devices that I'm going to get back, and I am going to be able to add those to the database. And let me show you how to do that. First of all, we need to iterate through the devices, and in order to do that, we're going to have a for loop. Now let me pause here and just point something out to you. Normally what I would be saying is I would say for device in something like devices, because I would have created a Python list that would have devices in it. But remember, import devices, what does that return? If I go here to import devices, it returns a list of devices. So when I try to play Python here, what is this going to resolve itself to? This is going to be a list of devices. Now, if we have 0 devices, then this for loop just won't do anything. But if we have devices, then we will iterate through the devices that have been read in one at a time. Now, the next thing that I'm going to do is this. I need to create a device object using the class that we just had, and I'm going to pass in data from the device that we're using in the for loop. So let me explain what this is here. What I've done is I said, okay, I'm creating a new variable here. I'm going to call it device object because it is going to be an instance of an object of this class. And now I'm passing it, and you may have seen this in other Python stuff that you've seen. This class name right here, device, what I'm saying is I want you to create one of these things. I want you to create an instance of one of these things. And what are we going to populate ID, name, IP address, vendor, etc. with? I'm going to pass in this device, which is the thing that I'm iterating through right here. So the first time through, this is going to be a Python dictionary, which is a device, represents a device, and it is going to have keys in the dictionary for the values for name, IP address, vendor, etc. So this is going to be a dictionary. The way that I need to pass it in, and I'm not going to go through this right now, is I'm using this double asterisk format or pattern for passing in this data. You don't have to worry about that right now. You can just copy it. When you understand Python a little bit better, you'll be able to understand this in a little bit more detail. But we're going to be passing in this thing called device, and this thing right here just turns it into what we call a keyword parameter. So we're passing in device, which is going to be, remember, it's going to be a Python dictionary that has this data in it. So it's going to be a dictionary with a key of ID, a key of IP address, and the associated values that you see right here. And so it's going to do that. It's going to create this device, this instance of a device class, which we call an object, and I'm going to call it device object. Now, the next thing that I'm going to need to do is I'm going to add it to the database, and that's what I'm going to type in next. Okay, let me explain what this is doing. So I've created this thing called device object. It is now an actual instance of this class. It's not a Python dictionary anymore. It is actually an instance of this higher level thing we call a class. And this class is of type that has been derived from SQL Alchemy. So it has a bunch of SQL Alchemy stuff associated with it for doing database things, but it also has my data, the ID, the name, the IP address, vendor, OS, and host name in it. That's what's in this. And now what I'm going to do is I'm going to say, hey, I want to take this database thing, which is an SQL database object that I've created, and it actually, remember, we're pointing it at SQLite. And what I want you to do is I want you to go and use this thing within it called a session within SQL Alchemy. We're always dealing with a database session, so this is just the pattern that you need to follow right now. And the actual function or method that I'm calling is add, and I'm passing in this device object. SQL Alchemy is smart enough to create all of the database code required to put a row of data into that table. And the data that's going to be put in there is what's in device object. Remember, device object was created by device. Device came from our import devices, so it is going to be a Python dictionary. So basically, think of it as Python data that looks like this, but it's going to be written into this database via the mechanism db.session.add. Now it's going to iterate through this loop right here for every single device I have. If I have one device, it's going to do it one time. If I have 20 devices, it's going to do it 20 times. So however many devices I have here and I've imported via my import devices, it's going to go and do that for every single one of those. And when it's done, this is the way databases work, and you may be familiar with this if you've dealt with networking devices. It doesn't become real until you do a commit. So when we're done here, remember I need to unindent to show that this isn't part of the loop anymore. And what I'm going to say is db.session.commit. And when I do that, it's going to actually write the data to the database. So this is all I really needed to do. in order to take the data from devices.yaml, read it in using this function, which I called right here. I called that function. It read it in from the YAML file. I'm iterating through the devices one at a time. And because I created this nice class called device, I'm able to utilize SQL Alchemy functionality to create an instance of that class, passing in the data from the device that I've imported. And then I am going to just add it to that database session, which means it's going to put it in the table. And when I'm all done, I'm going to do a commit. So let's take a look at this in action. Okay, so what we're going to do now is look at the database that hopefully gets created when we run our quokka code. And so what I wanted to show you first, here I've done a history just to see all the things I've done with SQLite. And you will recall, or you may recall, that I tried to install it early on using pip3 and it didn't install. And that's because I don't really need to use SQLite 3 directly. It is only getting used indirectly. If I want to be able to use SQLite for looking at the database stuff, then I need to install it into Ubuntu. And so that's what I've done since you saw me last, is I've actually installed SQLite 3 so I can run it. Now, what I'm going to do, you can see that when I have run it and examined stuff, the name of the file, and we can look at our code, that we store stuff in is from the root temp/testdb. How's that associated with this here? Well, look, that's exactly the same thing that's right here. So you could change the name of the file here and it would be represented differently in a different spot. But what I'm going to do is I'm going to get rid of that file. Okay, so now I've gotten rid of that file so that it doesn't actually exist at all. What I'm going to do is I'm going to start up Flask, and remember, just to remind ourselves, what is going to happen, we've put all of this code into a init. We'll move it someplace else eventually, but this is a startup sequence of what we're going to do. We're creating the database if it needs to be created, and then we're going to go through and for every one of those devices in our YAML file, which we import, then we are going to create a device object and we're going to write it out. At the very end, we're going to commit it. So let us start Flask and see what happens. So far that looks good. It looks like it hasn't crashed anyway. Let's go back to our SQLite and let's first see if that file is there. So the testdb file is there, which leads me to believe that it has been created. So I'm going to go in and examine this data to see if it exists. So I'm going to type in SQLite 3. I'm going to go temp test.db. And now I'm in SQLite. And in order to poke around here, you need to have some knowledge of database. And I'm not expecting you to learn all of this. You don't have to become an expert in databases in order to do this, but having a little bit of knowledge is a helpful thing. So what I'm going to do is I'm going to go back to a command that I've done before called .tables, and this will show me what tables exist in my database. And you can see here that there's a table called device in my database. And so what I'm going to do next is I'm going to say, show me everything that's in this thing called device. And the way that you do that in SQL type applications is you say select, and then you specify the columns that you're interested in. If you want all the columns, you say star, then you say the table that it's going to come from. So I'm going to say from device, and then a peculiarity of SQL is that you end your statements, at least the normal statements, with a semicolon. So I'm going to say select star from device. And if I examine this, then I can see, okay, well, there's 1, 2, 3, 5. There's IDs 1, 2, 3, and 5, but there are 4 items in here. If I was to go back to my YAML, then I can see I have ID 1, ID 2, ID 3, and ID 5. So I don't have ID 4 in here. So that looks correct. I'm going back here. I have 4 rows, and the IDs are 1, 2, 3, and 5. The data, it's not showing me this in any intelligent way, but I can tell that this is, I believe this is the name, this is going to be the vendor, this is going to be the OS, and this is going to be the host name. And these 2 upper lines right here are indicating that there's no data for that. That's actually the IP address. I don't have IP addresses for those, and that matches what we have in devices.yaml. I have empty IP addresses for those. Now, if we want to look at this a little bit friendlier manner, then what I can do is this. And I have these in the cache of commands, so I'm just going to go back here. The first thing I can do is say .mode column. This is an SQLite thing. You don't have to memorize this. I forget it every time, and I don't use SQLite all that often, but I just do a Google search for how to show columns or how to show tables in a more tabular or friendly format, and there's lots of stuff that'll tell you how to do this. If I say .mode column, and I'm going to go back and say select star from device, that makes it a little bit easier to read, or at least it would if I had made this wide enough. So here it's spaced everything out, and I can see here's probably the name right here. Here's the vendor, here's the OS, and here is the host name. And if I want to get a little bit more detail, I can turn the headers on. That's what I would do with this command right here, .headers on. And now I'm going to display this again. And it actually looks a little bit more like easy to read for a human. And you can see that I've got the ID over here, the name here, IP address, which I don't have, vendor, OS, and host name. So let's just pause for a second and appreciate what we've done. We've done a significant vertical slice of our application. Our application that we've created is able to create a Flask service. So this is going to be running all the time. It's running right now, waiting for REST requests, etc. I have created this view. When I go to views, I've created a single endpoint called /devices. And if I use that, I'm not going to pop up Postman right now because it takes a while to load. But if I were to go to that, I would be able to import these devices and return them. And if you're looking at this and saying, well, wait a minute, you already did import devices and stored them in the database. Shouldn't we be getting this from the database? And your answer is absolutely correct. I will end up getting rid of this and reading from the database in the next Quokka from scratch session. But this is the views that we have. So we have a REST API at the top. We have our Flask web service running in the middle. And what we did at the very beginning in their initialization, I guess it's appropriate this is in init, is I created my database tables, and then I iterated through all of the devices that are in that YAML file, and I stuffed them into the database. And what we see here is the actual output of that. We've actually put things in a database. So when you think about it, this is pretty much, it's not a full stack because it doesn't have GUI, but it does have RESTful API on the top, and it's got a database on the bottom, and it's got little amount of code. Really, when you think about this, what is this? 30 lines of code. I have database. I have also my views. I guess I'd have to count this in my lines of code, so more than 30. And I have this ability to read things in from a YAML file, and then I will eventually store them. So in my opinion, that's a pretty cool thing to be able to have done that. This is how we begin to use the database in the Quokka application. Admittedly, we slimmed down what we were storing, so we're only doing a subset of what we have defined here in our device model. We will expand that as we go through this process, but you get the idea of how to do database functionality in your REST full API web application service called Quokka.